Section 1.5 is the section on bias and sampling. It's a very important section to cover in statistics. If nothing else, when you leave this class, I want you to be able, when you're presented with data or conclusions, we're bombarded with all kinds of media these days. Especially, I mean, if you're on Facebook, if you're on, Twitter, all kinds of data are pushed to you, and I don't want you to blindly accept any of that. Question at all. If it's from CNN or Fox or the New York Times, wherever, I want you to read all of these articles, especially that present data and draw conclusions with a very, I don't mean this negatively, but be skeptical. Most of the time these authors have a slant and they're trying to convince you of something. And so bias and sampling is a very important topic to talk about as we go through statistics. So the sources of bias and sampling. Okay, so what is bias? Exactly. It's having, sometimes you can think of it as having a preconceived idea of how you want people to interpret what you're saying, as having favorites. Sometimes we show bias towards our children as a parent, or hopefully not to our students in our classroom, but it's almost like playing favorites, bias. And so it's an angle that someone might have, okay? If the results of the sample are not representative of the population, then the sample has bias. Okay? What does it mean when it says the sample is not representative of the population? We talked about that briefly. I know we said a lot last week. You want your sample to be as representative of the population as possible. I had the one example where I'd only picked males out of the classroom and said, would we want to only use them as our sample? Well, that is a valid sample from our classroom, but it doesn't give the female measurements. And so that would not be a representative sample from our population. So you want to make sure, if at all possible, that your sample is as representative of the population as possible. There are 3 sources of bias that we'll talk about: sampling bias, non-response bias, and also response bias. Sampling bias means that the technique used to obtain the individuals to be in the sample tends to favor one part of the population over another. Sampling bias. Let's suppose that I am the CEO of a pharmaceutical company and I've developed a new medicine. And that medicine is to lower cholesterol. Okay? And what if I knew something about cholesterol measurements of my population before I selected the sample, and I want to compare my medicine maybe to an existing medicine? And so what if I select a group that has a lot higher cholesterol level than another group, and I put them all in to use my new drug, and then maybe someone else who has controlled cholesterol better? This group's probably going to experience more changes just because they have further, their numbers are high to begin with. And so that would be sampling bias, where I'm favoring one particular group to be in a sample over another. Also, undercoverage. Undercoverage is a type of sampling bias. Undercoverage occurs when the proportion of one segment of the population is lower in a sample than it is in the population. That's exactly what would happen if I got a sample out of this classroom of only male students. The female would be undercovered. Does that make sense? And so you don't want to leave out a group unless it's actually missing from the population. Non-response bias exists when individuals selected to be in the sample do not respond to the survey. Okay. I guarantee you that pretty much any time your phone rings and you don't recognize the number, even if you answer it, you're probably likely to hang up on them the minute it says, "Is Ruth there?" That high voice, and they always ask for Ruth, it seems. until you hang up, right? So that's you've been selected to be in this sample at that point. But when you hang up on them, you've chosen to not respond. And so the idea is that people who choose to respond, they are different from the people who don't respond, okay? In lots of ways, the people that will stay on the line are people that may be lonely. A lot of times they're elderly. They may just be people that, you know, are needing to talk to somebody. And that's different from the people that don't have those characteristics. And you're like, I'm not going to give you my opinion. So they're not getting a good sample. They're covering one part of the population and not another. Oftentimes, too, let's say that a senator sends out a survey to your mailbox. And that happens here all the time. Tom Craddock, we get these regular surveys in our mailbox. And if you respond, you're oftentimes likely to respond if you feel strongly one way or another about whatever that survey is covering. Okay? So if the survey were about creating better baseball fields in Midland, Texas, or taking tax money to create baseball fields here in Midland, Texas, I'm likely to respond. My kids play baseball and I want better facilities for them. Okay? But if you don't have children, or you don't have children playing baseball, or you've got swimmers and you're like, I don't want to give any money to baseball, you might also be likely to respond because you want to say no. Okay? But those middle of the roaders, they're likely to not respond because they think it doesn't affect them. And so that's non-response bias. You might be getting the two extremes, but the others are the ones that are likely to throw away that survey. You can improve non-response bias through the use of callbacks or rewards or incentives. If you add a reward to the survey, then people might be more likely to respond. If you hound them to death, they might be likely to respond, or they're not likely to be very frustrated with you. So, non-response bias. Response bias exists when the answers on a survey do not reflect the true feelings of the respondent. If you ever have the opportunity to develop a survey, you need to have a very critical eye and mind when you develop the questions on that survey. Types of response bias and interviewer error. Interviewers need to be trained to obtain accurate information. If I were interviewing you about your statistics class, I could be interviewing always happens not face to face, but you can, there's personal interaction there, right? And I could say, one of the questions could be, don't you just love Colmia's stats class? You see some problems with that? Because I'm trying to elicit a response from you. I'm shaking my head yes, using the word love, don't you? I'm putting phrases into your mind instead of how do you feel about Colmia's stats class? You see the difference between the two? The interviewer needs to be trained to be very unemotional and almost just clinical. Misrepresented answers. People often misrepresent themselves. People like to exaggerate a lot. And if you're asking questions about how many days a week do you work out, if you are a person who only works out once or twice, you might say 3 or 4 times if you're responding. So you want to make sure that you can ask questions in a way that you're getting honest answers, if at all possible, from your sample. Wording of questions, this also kind of goes into what I said in number 1. You want to avoid leading questions. That question about, don't you just love Colmia's stats class? It's a very leading question. You don't want to lead the students into a response. You want to try to make your survey questions not have emotion either. How do you feel about Colmia's stats class? That's an emotionless question as opposed to, don't you love Colmia's stats class, or even don't you hate Colmia's class? Both sides of that have emotion. Do you see the difference? So avoid leading questions. The order of questions or words. the order that the questions happen, what you've asked in one question, if I started with, don't you love Colmia's stats class, and then the next question could say something about, you know, how do you feel about the support that you're receiving at Midland College? Well, if I've already put into your mind that you love something about Midland College, it could affect the later questions about the support that you feel like you're getting at Midland College. And so you want to have, if at all possible, if you can randomly have your questions presented to the people that are responding, that's a good thing to do too, because that removes some sort of systematic effect on your answers based on the ordering of the questions. So these are all response biases. Question number 1, determine the type of bias and suggest a remedy. Remedy means solution. How could you correct the bias? Let me try to zoom in here a little bit. The Village of Oaklawn wishes to conduct a study regarding the income level of households within the village. The village manager selects 10 homes in the southwest corner of the village and sends an interviewer to the homes to determine household income. Okay, so remember that we had 3 sources of bias. We had sampling bias, non-response bias, and response bias. Back here on this slide here. 3 sources of bias: sampling bias, non-response bias, response bias. You want to conduct a study regarding the income level of households within a whole village, and you're sampling homes in the southwest corner. What do you think? That is a sampling bias. Sampling bias is when you intentionally leave out a portion of the population as being a candidate to be in the sample. And so this is sampling bias. It's sampling bias because we're only using the households in the southwest corners. Every other household in this village did not get an opportunity to have their voice heard. So that's sampling bias. How could we correct that?
Stratified sampling.
Stratified sampling would be great. Maybe divide the neighborhood into northeast, northwest, southeast, southwest, and then within each strata, select 100 households or something like that. That's great. Or another way that's one solution. That's a great solution. Another solution is that you could cluster by the blocks in the neighborhood and then get a sample of 10 blocks, a random sample of the 10 blocks, and then use every household within that block. That would be a cluster sampling. Good. Even a simple random sample, if you had a list of all the residents in your village and you randomly select 500, that would be another way. You just want to make sure that every resident in the village has a chance to be in the sample and have their voice heard. Great. Midland College students are surveyed regarding their sleep habits. From a list of all MC students, a simple random sample of 100 students is selected. They are asked, how much sleep do you get? That's a response bias. It's not really an awful question, I don't think, but it is a response bias. And it's a response bias. Remember when we talked about response bias, we had 4 different types of response bias, and it's about the wording of the question. We haven't been specific enough, so it's wording that makes this a bad question. How much sleep do you get? What do you mean? How much sleep do I get in a month, a year, last night, on average? You know, one student could answer it thinking about in a week. One student could answer it just based on what they got last night. And so you want to be very specific about how you ask questions like this so that you can compare the answer from one individual to the answer to another individual. Okay? And so, you know, a way that you could correct this, instead of saying how much sleep do you get, you could say something like, depending on what you really are after, but on average you could say how much sleep do you get on each weekday night. And do you see how you might respond a little bit differently to that question than you did on how much sleep do you get? We're talking about weekday nights. Students may get less or more sleep on a weekend, depending on what their weekend habits are. Okay. And the answer to this question that we've just written, again, if it said on average how much sleep do you get on each weekend night, the answers might be two different things. And so it depends on what you're really trying to study. So be as specific as possible without trying to elicit a particular response. Just trying to get honest responses. An ice cream franchise is considering opening a new store in Midland. The company wants to know the percentage of Midland residents who regularly visit an ice cream shop. The market researcher obtains a list of households in Midland and randomly selects 150. She mails a questionnaire out to these 150 households and 4 are returned. That one's non-response, right? A horrible response rate. This one's a little bit harder. The non-response ones are hard to correct because if people didn't respond the first time, they're probably not likely to respond again. You can try to correct this, as our book says, with callbacks or repeating the survey or giving them an incentive. You know, we'll give you a coupon for a free ice cream cone if you complete the survey, something like that. So that's how you could correct this. So that is the end of this slide. You could just say offer an incentive. Are we okay to move on? Great. Other errors that you can have in data. Data entry errors. I'm sure that you've typed in numbers or data before and made a mistake. And so that's what data entry errors are for. Technically, they're not a result of response bias, but data entry errors will lead to results that are not representative of the population. When data are collected, the results may need to be entered into a computer, which could result in input errors. Or respondent may make a data entry error. For example, 39 may be entered as 93. You may transpose the numbers. So you want to be sure that you always check the data once you have entered them. The other day I was entering grades for something and the student had made an 80, but I hung on to the 0 a little bit too long and it entered it as an 800. Fortunately, Canvas puts it in red and says, this grade may be too large. I'm like, hallelujah, yes, 800. You don't have to do another assignment for the rest of the year because all your points are there in that one. So something as simple as entering data, I always need to check my entries there. We're going to talk about sampling error in detail as we move into later sections in our course. Non-sampling errors are errors that result from undercoverage, non-response bias, response bias, or data entry error. Okay, so here I'm using the word error and not bias. So sampling bias is when you have not allowed every portion of your population to be considered for the sample. That's sampling bias. But sampling error is the result. So what happens in statistics, if we can't get population data, we'll take a sample and use that information from the sample to try to infer what's going on in the population, to draw conclusions about the population. Now, the results that I get from the sample are not likely to exactly equal the same thing that I would get if I could get information from the entire population. Okay? If I could ask for the age of all Midland College students and get an average age from everyone that is taking a class this spring semester, that value would be different than if I only took a sample of 100 students and asked their age and got the answer. The difference between the value that you use from a sample to estimate the value that you really want to know in a population, that difference is your sampling error. And it comes from using a sample to estimate a quantity in a population. Sampling bias, again, is about your sampling technique. Sampling error results in using a sample to estimate a characteristic or a quantity in a population. And that is section 1.5. Any questions from it?